Okay, so in this video, let's understand what are the limitations of KNN. So let's say I have a data set, right? And this data set has n rows and it has d columns, okay? Which means that it is a d-dimensional data set. D-dimensional data set, right? So now if I want to find the time complexity of KNN, what do you think the time complexity will be? So to find the time complexity, first I let me just write the pseudocode here. Very simple pseudocode. First, I have to go through each data point, right? So first I'll take each data point from I equals 1 to n in the entire data set X. This will be, yeah, in the entire data set XD. Okay. When that happens, what I'm going to do is I'm first going to check the distance between each data set, between each data point. Okay. And then I'm going to select K. Then I have to select K, right? K is the hyperparameter for in KNN, right? We have to select how many neighbors we want for our data set. So now what happens is that if you carefully look at the pseudocode, right? What happens is that you have to. So let's just write the time complexity for the first statement. The time complexity for the first statement will be O of D, right? Where D is the dimensionality of the data set. Because when you check the data set between each data point, if you have a d-dimensional data set, you have to find the distance between each of those d dimensions. So when you find the distance between each of those d dimensions, you will see that the time complexity is O of D. And here the time complexity is O of K. Okay, K can be anything 1, 3, 5, 7. But since O of K is much, much lesser than O of D, right? Since O of K is much, much lesser than O of D, we approximate O of K to O of 1. Because if you look at the dimensions, there are datasets that have 100,000 columns. And comparing 100,000 columns with K, where K, the value of K is 1 or 3 or 5, it doesn't really make a lot of sense. So we approximate the value of O of K to O of 1 because O of K is much, much smaller than O of D. But the important point to note here is that for each data point in the data set, when you check the distance between the data points, you'll see that the time complexity is O of D because you're finding the distance between, if you take something like the Euclidean distance, you're finding the difference between each dimension, and then you take the square, you add them, and then you take the square root. So that's O of D, right? And there are n data points. Okay, so this loop runs for n data points. So ultimately, the overall time complexity becomes O of nd for our KNN. Overall time complexity. Now, it's not uncommon to have a data set with a million rows and 100,000 columns. So if you look at it that way, O of 1 million into 1000, well, this is a huge number. Even if you take milliseconds over here, this can run into hours, right? So this is the time complexity, and we look at it's very high. The time complexity is very high. And if we look at the space complexity, the overall space complexity, so when you have to compute all of these, when you have to do this computation, you have to store it in your RAM. And the space complexity here will also be O of n into D. Okay, because you have n rows and D columns, so you store it in a table O of n into D. and that will also be a space complexity. So for the KNN, we have time complexity, time and space complexity as O of ND. And this can be a very, very big number. If you have a million rows and 100,000 columns, this number will be huge. And so if you use this, if you want to use this technique in, let's say, if you work for a web a huge company like Facebook or Amazon, where you need the response from the model in less than 1 millisecond. I mean, the customer can't wait for a minute for your model to compute. If you give it some new data point XQ into the KNN model, it should give you the output in about a millisecond or so. Now, if the space and time complexity is this big, this can extend into something like 1 minute or 2 minutes, and no customer is going to wait for 1 minute or 2 minutes. They're just going to run away. They won't use your product ever again. So that is one of the limitations of KNN, is that it's very slow and it's also very memory intensive. You need huge RAM to store a data set, to store the KNN training data set in your RAM for computation. So the space and time complexity of KN is O of ND, and it's very large. N is the number of rows and D is the dimensionality of the data set. So now to overcome these limitations, we have some other techniques like the KD tree and the locality sensitive hashing, okay, which I will cover in the next videos. And these techniques themselves have some limitations of their own, but they do improve upon the time taken for complexity, like O of ND. They are usually faster, okay? So I'll stop the video here and I'll see you in the next video.